Alright, hello everybody. Today's day 2 of doing some Neet code, and today I'm going to do valid anagram, which is, if we go to line 75, it is the second one, and I've done it once before, but it's been a minute, so I'm going to try and do this again. Now let's read over the problem together. Now, from what I've seen, there are multiple ways to approach this problem. I'm just going to approach it from the sorting aspect, and then we can look at the other solutions and I can try and implement them by myself. But yeah, let's start with reading over the problem definition, and then we can go over the solution. So a valid anagram essentially is saying we have two strings and we will return true if they are anagrams of each other, meaning race car and car race have the same exact amount of individual letters. So like we have two R's in this string and two R's in this string, and we have two A's in this string and two A's in this string, meaning if we have the exact same number of chars of a given char and they match in length, then we have an anagram that we can make, because it doesn't matter if we sort or move around the letters as we're trying to figure out if they're anagrams. It's, hey, if we have three A's in this one and three A's in this one, then they match. And we can see here, if we have a J in this one, a J in this one, an A in this one, an A in this one, but an R and then an M, that doesn't match, so we return false. So, pretty simple way to do this, O of n time, is we're just going to do a sorting. We're just going to sort everything, so we'll sort each string from essentially alphabetically. It'll put it in A to Z. So if we do sort, which it would be std sort in C++, this is what we're going to do it in today. We do s.begin, which is meaning we're going to start sorting from the beginning of S, and then we're going to do s.end. So this operation tells us, hey, we want to sort everything from the beginning to the last character in the string S. And we'll do the same thing for t here. So we could do t.begin, and then we want to do t.end. Now this is a very easy approach. This is something I would say, hey, if I want to come up with a solution that just gets the job done, I would do this. Now we want to say, hey, if actually, before we do that, we want to check if the lengths are the same. So we want to say if s.size, which means the amount of characters in S, does not equal t.size, meaning if they're different in any way, like let's say that string S has one more character than t, then they will automatically return false, since those cannot be equal. And then for here we would do, sorry, my keyboard is being funky. Let me replug it in. Now since after we sorted them, we would return S is equivalent to T. So now since they're sorted, we would only, and if they're the same size, then after they're sorted, we will return if they are equivalent. So and we can see if we do that, we can submit that, and it's 4 milliseconds runtime, which is not bad. I mean, you can see here there's a whole list of these. But let's look at the other solutions and see what other things we could do to make this run faster. So let me just reset this right here. And let's go to solution, and if you watch the video, it's a great explanation for the different approaches we can take. So the one I just did is a sorting solution, and that has a time complexity of O of log n plus m of log n, and then space is O of 1. So not too bad actually, pretty fast. A hash map would be O of n plus m, which is still really great. And then we could do a hash table, which you can see here, this is a lot more code for both of these. So, which isn't necessarily a bad thing, but these could be more efficient depending on the problem that you're doing. But let's write this one line by line, and then we can both have a good understanding. So we'll still start by doing the same s.length, and we'll check. It will check if they are the same, which we're not doing s.size, because I'm assuming it's because there's two different methods. So let's actually look this up. String methods in C++. This could say that we have s.length for a member method. So let's go. We have iterators, capacity, and then we want to do the size. So let's say these are all modifiers. Element access, we got back, front, at, and then let's see, member functions. So we can look, s.size should be in here. This is how I typically will look up what the member functions of the std or the standard template library class have. That way it's an easy way to understand. So let me see if we have size on here. Oh yeah, right here. So we have size and length. Return the length of the string. These both essentially do the same thing. So we can just try it with length and to just showcase that it works. Same logic. Also, I did do not equal. So, and then instead of doing sorting, we will do a hash map, meaning we will map every character in, and then these will be char to an index. So we'll map every character in the first string and second string to what the character is, and then the index that it's at. And then we could call it count s, and then we'll do the same thing, map char, and then int, and then this would be count t. And then we basically just want to iterate through everything in this would be O of n time to iterate once through everything in s. So we'd say int I, and then we would do I is less than s.length, and we only need to iterate over one of the pair of strings, because if they happen to not be the same length, then that doesn't matter at that point. So we just say count of s, and then we do s, and then the index, and then we'd increment that, and then we do the same thing with t. So, to my knowledge, the reason that we're doing this, let's actually read this really quick. Increase the character count for s of I and t of I, so meaning we're going to add these characters to the map, and then we will compare if the count of s and count of t is true. So count of s is equivalent to count of t. So a lot of the logic with tracking the characters themselves is handled as we go and iterate and map every character. So that's the nice part, is these are maps, and then we want to assign the index and increment that index, add it to the map. And then after it does all that, after it goes through every character in those strings, then we would just return, hey, count of s is equivalent to count of t, and that would return the true statement. So if we run this, it should work. And yeah, we can see here, and last second I believe it was 4 or 5 milliseconds, and this is 3 milliseconds, so still pretty great. I'm assuming there could be more efficient solutions if we don't use any. I mean, we could probably, this is probably the best thing we can get, but I mean, it's pretty good still. I would say that maybe the hash table would be better. Let's actually copy this and see what the efficiency, the runtime would be for this, because it's all very different. This is just mapping every character in the alphabet, which is 26 characters. So let's submit that. And that's still 3 milliseconds. So it's really just a matter of what you are comfortable with at that point, which I personally would rather just do a hash map or the sorting. But if I was looking for something more faster, I would do the hash map. So yeah, thank you guys for watching today, and I will be back again tomorrow with the next problem, and I'm just going to keep doing the learning on the side of each data structure and algorithm, and I will keep coming back every day as much as I can. If you guys have any suggestions, please let me know. And if you guys have questions on any of these solutions or attempts, let me know. So yeah, thank you guys. Have a wonderful day.